Welcome back. In this video, we're talking about the dining philosophers. The dining philosophers is a common problem in computer science. It's an example or an illustration of a very common thing in computers. So here we've got 5 philosophers sitting around a table for food. There is 1 fork between each pair of philosophers. So we've got 5 forks, 5 philosophers. And each philosopher has endless hunger and endless food. So let's say there is a lot of food on the table and they are extremely hungry. But in order to begin eating, one philosopher must have 2 forks, 1 for each hand. So as you can see, there is not enough forks for everybody to go round. So how would the philosophers tackle their problem without talking to one another? Well, obviously there is a problem, which is if each one of them picks up 1 fork. If each one picks up their left fork, say, or in this case their right fork, they then are going to wait. Then they're going to pick up the right fork and wait, and they're going to eat, put the right fork down, and then put the left fork down, and then start again. But if everybody picks up their right fork, and then they're going to wait for the left fork to become available, they could be waiting for a long time, because every philosopher is also waiting for the other fork to become available. None of them releases their fork, so they all end up starving, waiting for the other fork to become available. So if the solution involves waiting for the fork to become available, they could potentially starve. So we don't want that. The problem is that if all the philosophers pick up their forks simultaneously, nobody can pick up the other fork. So they keep waiting indefinitely and they end up starving. Similarly, if any of the philosophers does manage to start eating, somehow taking up 2 forks, they may never stop eating. And so the other philosophers are forever without 2 forks, and now they've got to share 2 forks amongst 4 philosophers. That's even worse. 3 forks amongst 4 philosophers. So what can you do to solve this problem? There are many ways to solve the problem, and these are normally covered in concurrency courses, computer science degrees, so on. Not going to get into too much depth, but normally the easiest, simplest way, which is how Python itself does it, is to have a waiter at the table, like this one. So what can happen now, the way we could restructure our algorithm, is to say that a philosopher can request 2 forks from the waiter. And the waiter will give it to them if they are available. And then when a philosopher has 2 forks, they're going to eat for a fixed amount of time. And after, they're going to return the forks to the waiter, and the waiter can then give it to other philosophers and so forth. So something like this could happen. One philosopher could ask for 2 forks, and then the waiter will be like, sure, take 2 forks on the table, and give them to the philosopher. Now this philosopher has 2 forks, and all the other philosophers are doing nothing. Then some time passes, maybe 10 minutes, and then the waiter will take the forks back, give them back, and I will take the forks back, and I'll put them back on the table. Now, one philosopher has not starved, which is good. The other 4, however, not so lucky. Instead, what could happen is something like this. We could get all the philosophers asking for their forks, more or less simultaneously. Remember, nothing can truly happen simultaneously, at least not in Python, okay? Because there is a limited number of forks in Python, let's say. So all of these people ask for the forks more or less simultaneously, but there is someone that asks for it first. So that person, let's say number 1, is the first person on that list that you see at the bottom right. The next person to ask for forks was number 2, and then 3, then 4, and then 5. So let's say they asked for them in order. So what happens then is the waiter first gets 2 forks, give them away to number 1. Number 1 is now on a different list, let's say. Now it's on a different waiting area, on an eating waiting area, let's say. Then we still have forks available, so the waiter would take 2 forks and remove 2 from the list of waiting for forks, give them the forks, and put them in the list of, say, eating. So now we've got 1 and 2 are eating, 3, 4, and 5 are waiting. Then, number 1 finishes eating after some time, so the waiter gets the forks back. Number 1 disappears from the eating list. Forks go back on the table. Number 1 goes now at the end of the queue. 3, 4, 5, and then 1. Similarly, after some time, number 2 finishes eating, disappears from there and goes back onto the other list. Now, if we were to repeat this process, the next person to get the forks would be number 3, and then number 4, then number 5, and then we would start over. So as you can see, this enables each philosopher to eat, not all at once, but they all get to eat eventually. So what's happening here is that we have a limited number of resources, in this case forks. And with these resources, we can at most run 2 things at the same time, 2 philosophers. Because 2 philosophers take up 4 forks, so there's only ever 1 fork left over, and a philosopher cannot eat with just 1 fork. So it does not matter how long and hard we think, the simple truth is that there is no way that we can have 3 philosophers eating at once. But what we can do, though, is trick the mind into thinking they're all eating at the same time. If instead of giving each of them 5 minutes before releasing their forks, we give them, say, 5 seconds or 50 milliseconds, someone looking may not be able to tell that they're not eating at the same time. Very much like a movie is just a set of still images, one after another. If the passing of forks happens sufficiently quickly, we won't be able to notice that it's not happening all at once. So if each philosopher eats for 1 millisecond, it would look to an observer that they're all eating at the same time, whereas really, they are not. So remember, even if we can't see it, it doesn't mean that it's happening all at once. Okay? And in Python, this is particularly important because Python cannot run multiple things at the same time. We're going to look into this more very soon. So now that we know about the dining philosopher's problem, we are ready to move on and start looking at how things happen in Python. With that said, I'll see you on the next video.